म्यूट है कई सर। वालेकुम सर।
Jangan lagi dulu berdua aku.
2 बजे
Ya?
2 बजे
2 baju. Baju mi berantak. Tangan luar.
Okay. Bismillahirrahmanirrahim. I welcome you all to this online class. Good morning, everyone, and I hope that everyone will be fine and safe. Sorry, once again, the university has been closed, but it is due to circumstances which were beyond our control. So, but I know our students are quite mature and they know how to use the online resources. Last time, if you remember, we started a topic on manufacturing systems, and we went through some basics of the manufacturing systems. Objective was to give you an idea that when we use the operations or when we go for the operations, where these operations basically lie. So if you remember, we defined the manufacturing system, the production system, then the manual manufacturing systems, mechanized, and then the automated manufacturing systems, and defined those three major categories of production, including the mass production, batch production, and job production. When we say production, so the production, I mean, it doesn't start automatically. Obviously, you design a system based on certain inputs, and one of the inputs is the forecasting. Forecasting, although you might have covered it in the previous semesters, but I feel it is better to give you, I mean, to brief you again on the forecasting, because that is the starting point for the designing of any manufacturing system. And obviously the other operations which are, I mean, then used while managing the operations of any production or manufacturing system. So let me share my screen with you. I hope other students will also join me. Presently, there are 13 participants in this online session. So hopefully the other students will join me. Probably it's quite early in the morning, and I'm sorry, but we have scheduled other classes as well. So that's why we have to start, I mean, accordingly. Let me share the screen. I hope everyone can see the screen.
Yes sir, ठीक है बिल्कुल सही है.
Okay, thank you very much, Ishtiyaq. Let me minimize this and maximize. Okay, so we start with forecasting. You see, you cannot think of starting any business without first forecasting what you are actually producing. Whether it is something in the discrete form, means products or services, but you have to forecast. After forecasting, then you know that this is the actual demand for you per year, and accordingly you have to arrange your resources, whether you have enough capacity to produce according to the forecasted quantities. Remember, it is not only the forecasting. There is demand which comes directly from the customers, because they can put their demand anytime to the organization which is producing that particular product. So a demand management is basically created or developed. So forecasting plays an important role, because you forecast the production of your products based on certain data, which is the past data, and then along with the customer's demand, you make demand management, and accordingly you split their demand into monthly and then weekly, which of course we do that in the master production schedule and in the material requirements planning, which is known as MRP. So this is the starting point. Here, what is forecasting is the definition. So it's simply it's like predicting the future using the data which you have in hand. That data could be based on the historical data, which is time series data, time series related, or some other factors which we use to project the future, or we predict the future. So basically the function is to predict the future using your data which you have. And why is it important? Because it helps us in making the decision. Like if your forecast and customers' demand is too high, for example, from your capacity, then obviously you are going to either outsource some of the the products which are going to be produced, or you might go for the extra resources by investing money in that, or you may not entertain the orders. So there are various situations which can arise later on. So that is the objective, to help you in making decision today. Where is the forecasting used in the operations management? So forecasting basically, we forecast a demand for the products and services, forecast the availability or need for manpower, and we forecast inventory and material which is needed on daily basis or weekly basis. So that is that's the use of the forecasting in the operations management. Okay, what makes a good forecast? So a good forecast should be timely. It should be as accurate as possible. As accurate as possible, it means it is always subject to errors. The forecast is always subject to errors because you cannot predict the future using the past data 100% accurately. So that's why it should be as accurate as possible, and it should be reliable. It should be in meaningful units. Usually it is in terms of the SKUs, stock keeping units for products. And for services, obviously, when we say for services, you cannot measure it in terms of the SKUs, but usually in terms of dollars. So dollars, again, they are related. Dollars are money, right? When we use forecasting for services, so you cannot measure it in terms of units. Obviously, it is in terms of money. Could be rupees, could be dollars, could be any other currency. But that currency is, again, there's a unit price of a product, right? Or a part. So when that is multiplied with the price, with the number of units, the price of one unit multiplied with the number of units you produce, again, that can be measured. And these are quite meaningful units. Then it should be presented in writing. Obviously, you must have the forecast, in a written form. Verbally, if you go verbally, obviously you'll be lost somewhere. You may not remember what you actually said initially, and then what is produced. So it could be more, it could be less. So obviously it should be in written form. The method should be easy to use and understand in most cases. Okay, these are various techniques which are used. Some of them are, subjective, some of them are objective. The subjective forecasting techniques include sales force composites. So obviously it is the forecast which is coming from the sales personnel, people who are in the market, are they know how many products are basically sold. So basically it is the aggregation of sales personnel estimates. Then we have customer surveys. So from the customer surveys, you can even know it's like a market research. So in the market research, once the data is collected, then we go for some hypothesis, and using the hypothesis accordingly, then we come to know that how much is required. Then the jury of executive opinion. So jury of executive opinion is a technique where senior people of the organization, they get involved and they basically provide their opinion about the forecast, usually top managers, etc. Then we have Adelphi method. So in the Delphi method, individual opinions are compiled and considered. I mean, you ask various people, uh, including the experts, including the people within the organization. So individual opinions are compiled and considered. These are anonymously shared among group. You don't mention their names, so that is anonymously shared among the group. Then opinion request is repeated until the an overall group consensus is arrived. So whatever is the consensus, I mean, that is the forecasting. The patterns of demand. I mean, in this figure, if you see, quantity is shown on this y-axis and time on the x-axis. So there are various patterns of demand. And accordingly, then we come up with the techniques of forecasting. Patterns of demand, that is the actual demand. And then for that actual demand, once you have the actual demand, from there on, then you can predict that this will be the pattern in the coming times. So pattern of demand, for example, in the first case, you see this red line. I mean, it's a zigzag line showing some variation with the passage of time, but I mean, you can see it is predictable. It goes almost horizontally. So it's a data cluster about a horizontal line. If you draw a line from this, that will be a horizontal line, and data is basically clustered around that horizontal line. So it's a horizontal data clustering data. Then trend. So trend is it could be an increasing trend or increasing demand with the passage of time, or it could be decreasing. So one can predict that there is a trend in the data going upward or coming down. So increase and decrease can be seen from the pattern of the demand. Then we have a seasonal data, seasonal demand pattern. So seasonal demand pattern, like say this is the year one data. So this was the demand pattern, and in the next year it followed almost the same pattern. It means the effect of season on the data is there. And when we say the season, it means the period during which it varies. For example, the demand for cold drinks. So the demand for cold drinks in winter, that is quite low, because people usually prefer the hot drinks, for example, tea, coffee, etc. But in summer, the demand for the Pepsi, for the cold drinks, for example, that goes high, because people love to drink cold things. So that is, I mean, and that pattern exists, I mean, every year. So that is the seasonal demand, where the demand varies according to the season. Then we have the cyclical demand pattern. So in the cyclical, basically, it is spread over years, and the duration of variation is not fixed. Unlike the seasonal demand, in the seasonal, we know that it varies according to the season, and the season remains for this much period, for example. I mean, like summer, so we know summer is for 3 or 4 months, so that there will be high demand. And in the winter, I mean, again, the season, the period exists for 3 or 4 months, so there is low demand. But in the cyclical, this period, I mean, this varies, and it is not known. So, for example, you see the quantity varies It is coming down, down, down until this year. I mean, it is just a pattern. It is not showing a particular example. So it is coming down, or it's varying, and then it is increasing. It is increasing, but you just look at the x-axis. It shows years. So year 1, year 2, year 3, and then it goes up, and so this is basically the cyclical data. Demand pattern. Then we have demand forecast applications. I mean, you might have heard the short term. It is from 0 to 3 months. It could be days and then goes into months. For example, 3 months. So 0 to 3 short term, 3 months to 2 years. We say, for example, it's medium term, long term, 2 years and more. So if that is the case, on the time horizon, and we are going to use some forecasting technique. So if the forecast, here the first column shows application include showing the forecast quantity, the decision area, and then the forecasting technique. So what we are going to forecast, and in which particular area to help us in making the decision, and then the technique. So the forecasting quantity, I mean, it could be the individual products or services. Individual products or services, that is the thing which we are going to forecast. The decision area is inventory management, final assembly scheduling, workforce scheduling. Like, we cannot schedule the workforce in the next 5 years, for example. I mean that will be quite strange. So usually it is done in the short term. So workforce scheduling, then master production scheduling. The master production scheduling basically includes the quantities and their due dates, the date on which it is due. And usually it could be in days, or it could be in weeks or months, for example. But it doesn't go into years. The master production schedule is split into days and weeks. And the forecasting technique, which can be helpful for such kind of forecasting, short-term forecasting, that could be time series, Causal. Causal means the regression techniques or the judgmental techniques. So those techniques can be used. The same thing, the forecasting quantity, if we are going to use it for the medium term, total sales, right? Total sales per year, for example, total sales, groups are families of products or services. Over here we have individual products or services, but here total sales are groups are families of products or services. And the decision area, staffing planning, because accordingly we can plan that we will require so many people. So staffing planning, but it is not the workforce scheduling. You can schedule it, exactly according to the application. But here, staffing planning, production planning, master production scheduling, right? Master production scheduling, then purchasing, distribution, and the techniques which can be used for the medium term could be causal and judgmental. In the long term, total sales, the decision area. Once you know that the Abdul Qadir Khan, you raised your hand. Please ask a question.
Yes,
If
thank
you
you so
have
much.
any question.
Actually, I wanted to ask
Unmute
that.
your mic.
Am I audible? Sir, am I audible?
Yes.
Okay, sir, I wanted to ask that, for example, in the short term and in the medium term,
Yes, I can hear you.
Okay, the master production scheduling is mentioned in both the sections. So, how? I mean, I didn't understand it. So, would you please elaborate on this?
Yes, the master production schedule. I mean, you see, that is the when we forecast something, when we take the customer's demand. So usually that is per year. So from there, from per year, we can make the master production schedule as well. But usually we split that to months and weeks. Because at the end of the day, whatever is in your master production schedule, I mean, you will meet that thing. So we split that to be more accurate. So that's why the master production scheduling is there even in the medium term, which is from 3 months onward, because it could be 4 months, 5 months, up to a year, for example. So that's why it is included in the medium term as well, because we split the demand management into master production schedule, right? Master production schedule, and then the master production schedule can be further splitted into weeks and days. Did you get my point?
Yes, sir. Thank you so much.
Okay. So in the total sales, once you know that this year your sales were, for example, X number, previously in the previous year your sales were, I mean, Y number, and say that your sales are increasing every year, and you want to install a new facility. So that facility location capacity, if your sales are increasing, so what will you do? And I mean, if you have a good standing in the market, obviously you are going to invest more in the facilities. So accordingly, you basically go for the capacity planning. That will you have enough capacity to meet the increasing numbers or increasing demand? So capacity planning is there, and then process management. How to basically then handle it, right? So capacity planning, process management, and again the forecasting techniques could be causal and judgmental. So let's go through this first one, which is causal methods. We use basically linear regression because that is easy to explain. Otherwise, we will need, I mean, if our variables are more, then we need to seek the help of some software. Anyway, the linear regression technique, here we have the dependent variable, and we forecast basically the dependent variable based on the independent variables. The example could be, for example, generation of electricity. People are having the problem nowadays in Pakistan. Not like sorry, mute. Please mute mic. Please
بس فل چوب شي فل ارته یو بل چا سره کار بل لري
please.
د شپې د مور مړو را په سر کړي کله بار کله کله دنه تا په ټول کور بازار ځان
The mic on है किसका उसको
اول بلاغه سیاست وای
Ishtiaq, are you there? Please control them. Ishtiaq, if you are online, please mute their mics. आपने जो कि ठीक नहीं है, मतलब आप सब लोग सुन रहे हैं, obviously I'm listening to it. तो आप इनको बंद कर दें इन चीजों को. Okay, so I was giving you the example of electricity generation. So the electricity generation, I mean, say we want to we want to predict the electricity generation by for 2005. Now, year 2025, obviously there are a number of independent variables. Increase in population, जो आपकी हो रही है population ज़्यादा हो रही है, वो किस rate से बढ़ रही है? Then the number of houses being constructed, the number of electrical appliances जो कि घरों में आ रही हैं, और मुख्तलिफ किस्म के factors हैं. So a number of factors then play their role in order to predict in order to predict a dependent variable, and dependent variable जो है forecast है. So linear, that is multiple linear regression. In linear regression, over here we are going to use one independent variable, right? One independent variable. उससे आपको technique का पता चल जाएगा. Obviously, if it is the number of variables are more, then you can use the software. Okay. So are basically our जो हमारे वो है data है हमारा, and we fit the straight line between them, which is known as the regression equation. And regression equation is y is the dependent variable, that is equal to a plus bx. I know you people have gone through it in probably in production planning control subject, but anyway, it's a refreshing kind of session today. So y is equal to a plus bx. A is the y-intercept. Now, what is y-intercept? Y-intercept is the point if you extend this line, and it is going to cut the y-axis somewhere here. So that point is basically the y-intercept. B is the slope of this line. Which is slope independent variable. Okay. This is these points are basically values of x to estimate y. Estimate y, yahan par hogi, if you go straight, this one. And so this is estimate of y from regression equation, and this is the error, the deviation or error from the actual point or actual value of y to this line, regression line or regression equation line. Now let's go through an example. The supply chain manager seeks a better way to forecast the demand for door hinges and believes that the demand is related to advertising expenditures. The following are sales and advertising data for the past 5 months in thousands of units, and this is the advertising in thousands of dollars. The company will spend $1,750 next month on advertising for the product. Use linear regression to develop an equation and a forecast for this product. ये sales है उनकी, और ये sales के साथ जो depend करी हो basically उसकी advertising पे. अगर जैसे यहाँ पे 2.5 multiply by 1,000, so that will give you $2,500. अगर आप advertising पे इतना उन्होंने लगाया है उनको उनके products को, so ज़ाहिर बात है sales उनकी बड़ी हैं. तो ये मुख्तलिफ sales हैं और ये है उनकी advertisement में investment. वो कह रहे हैं कि अगर हम इतनी investment करें advertisement पे $1,750, आप उनकी sales क्या होगी, यहाँ पर sales क्या होगी? So that is the question. Okay, we have 5 months, sales in thousands of units and advertising amount in thousands of dollars. Okay, these values are calculated here. The y-intercept, which is A, that is minus 8.136. It means it is bisecting or it is cutting this line below 0. Slope of the line is 109.22 x. R is the relationship of the variables, and this is the coefficient, which is basically squared. This value is squared, and this is the variation in the data, or basically variation within the error. Sorry, variation within the error. Error क्या है? Actual values of y from the regression line. How do we calculate them? That is shown next. But anyway, this is the summary of this whole. And from here we can make an equation, and the equation is in the form. It is the same thing. Sales in thousands, and this is A, because y was equal to a plus bx. So A is minus 8.136 plus bx, and forecast for month 6. जो month 6 की forecasting है, because it was mentioned that if you invest so much in the advertisement, what will be the sales quantity? So this will be the sales quantity. Y is equal to this thing, because this is 1.75. 1.75 because it is the same thing. 1.7 multiply 1.75 multiplied by 1000, or you can directly write 1750 over here. So that comes here. I mean, that is the quantity. This is, you see, yeah. This is the quantity which will be the forecast, which is coming here. 1.83 thousands multiplied by thousands. So many units. If current stock is 62,500 units, how much they need to produce? If the current available stock is so much, so obviously that this quantity will be subtracted from the forecast. So they need to produce so many units. 1.20 multiplied, calculated. So in order to find A, which is the y-intercept, that is equal to y bar minus bx bar. Y bar, obviously you can make this y, this one x, and in the slope, since we need the interaction of x and y, so that is shown in the slope of y bar divided by sigma x square minus nx nx bar square. So to get these interactions, they are multiplied first in this table. This is y, x, xy, x square, y square, and that's what is. I mean, these are actually needed while calculating the y-intercept and slope. These are the calculations. If you add them, divide them with 5, you will get y bar. Similarly, you will get x bar. This is sigma xy because it is required here. And this is x square because that is also required. And y square. Right? So this is how we get the slope and y-intercept. minus 8.136 and B 109.22. And then the same equation जिसको अभी हमने यूज किया था. And this is the relationship coefficient. This is the way we calculate it. Now, its value in this particular example is 0.98. The higher the value, the stronger is the relationship between the two factors. And then R square and then sigma yx. Sigma yx means dispersion within the this is the same thing. Invest this much money is going to forecast the number of hinges, which is कितने बनते हैं ये 183 multiplied by 1000. So obviously this number, so many hinges are required with the investment of this $1,750. Need the historical data, past data, including the let's start with an example, moving average, because there are enough time series techniques like moving average, then the weighted moving average and exponential smoothing, seasonal trend, etc. So compute a 3-week moving average forecast for the arrival of medical clinic patients in week 4. The 3 weeks were as follows. पिछले 3 weeks थे, उसकी मतलब ये pattern है. Week 1, 400 patients arrived. Week 2, 380. Week 2, 380. Week 3, 411. If the actual number of patient arrivals in week 4, remember actual, this is not the forecast number, this is the actual. If the actual number of patient arrivals is in next week, in week 4 is 415, what is the forecast error for week 4? Forecast error for week 4. So it means we need to forecast it as well and then check it with the actual. And what is the error? The difference between the actual and forecast quantity or number. And what is the forecast for week 5? Uski forecast kya hai? Remember, it is the 3 weeks. Our 3-week moving average. On this side, we take the number of patient arrivals, number of patients, then week, and this is the pattern shown. Give me a minute, please. 1 minute, मुझे दें. Hello, अस्सलाम वालेकुम शकूर. वालेकुम. Uz da class aħna żdina farix żdina marda rasunħa. Online non-meeting they are in the QC. زز النمبر درسته ها اليوم بس زز النمبر درسته اوكي please give me a minute. 1 minute आप मुझे दें. Oh, I'm sorry. So here we have the patient's arrivals and then week. So as it was mentioned in week 1, there were some patients arrived in week 2, in week 3, and then they asked us to predict the forecast for week 4, when the actual demand was also mentioned, like here. If the actual number of patient arrivals in week 4 is 415, what is the forecast error for week 4? So for forecast error, obviously we need to find the forecast for week 4 as well. So anyway, this is the actual pattern. Week 1, 400, week 2, 380, week 3, 411. And it is a 3 weeks moving average. So we take we sum them up and then divide with 3 because it's 3 weeks. So this will be our forecast for week 4 for this week. So our forecast is 397. So from here, 397. This is 390, and then you can check where the 397 lies. So this point. This is the forecast. Similarly, for week 5, the forecast will be again the three weeks moving average. And in the 3 weeks moving average, since you got the actual demand for week 4, which was 415, so again we are going to take the 3 months moving average, and that will give us the forecast for the week 5, which is 402. So this goes on, right? And then this greenish line, it shows the 3 weeks moving average forecast, while this red line is the actual data. So obviously, the forecast, as we mentioned earlier, that it is not 100% accurate. There is the error lies in the forecast. So we need to come up with a technique which should be much closer to the actual, so that your forecast is. And if we go for a 6-week moving average forecast, I mean, that will be the pattern. That slightly gets straightened because it dampens out the effect of variation within the individual weeks. So if you go for higher moving averages, so that will dampen out the effect of variations. Then weighted moving average is another technique in which we assign weights to the time periods, right? Weights to the time periods. And usually more weight is assigned to the recent past. Now, a recent past, you can pick it in a way. For example, we are in week 4, so it means week 3 was our past, so that is quite near to week 4. Week 2, that is slightly away. Week 1, that is more away from week 4. So that is, I mean, you can take the recent past in that sense. So we give more weight to the recent past. So t, then t minus 1, t minus 2. You see the weights are decreasing. So that is the secret, that more weight is assigned to the recent time period, recent past time period. If you are going to forecast for week 4, right? Week 4. So this is just an example, right? The sum of the weights should not exceed 1. So if you add them, it is equal to 1. So 0.70 is assigned to week 3, then 0.20 to week 2, and 0.10 to week 4. This is week 3, week 2, week 1. And from here, then we predict. Now, this is 403. In the previous case, where weights were not assigned, that was simply moving average. I remember it was 392. Now it is 403, much closer to the actual. Right? Much closer to the actual. I mean, that this was the point in this green line was the point, this point, using the 3 months moving average. When weights are not assigned, it means every period is given a weight of 1. So when you multiply 1 with the data, you will get the same thing. So while here we assign weights, and it is closer to that one. Similarly, week 5, 410, it was somewhere here. यहाँ पे ये point था कोई, अब ये है, which is closer to the, although yeah, not closer, I think is, but the overall, the average will be, I think, much better. 410. Okay, then we use the exponential smoothing. Exponential smoothing, reconsider the patient arrivals data in the same example, 13.2. This is basically chapter 13.2. I have taken it from a book which is Operations Management by Lee Krojewski, Ritzman, and Malhotra. You can find this book on the net, as well as probably a copy will be available somewhere in our library. So it is chapter 13.2 in that book. It is now the end of week 3. Using alpha equals 0.10, calculate the exponential smoothing forecast for week 4. What was the forecast error for week 4? If the actual demand turned out to be 415. What is the forecast for week 5? So almost the same example, but here we are using the exponential smoothing with the value of alpha. Alpha, what is alpha? That is the exponential smoothing factor. So exponential smoothing factor alpha is 0.10, as mentioned. And this is the way we forecast using the exponential technique. F subscript t plus 1 is equal to F subscript t plus alpha into d subscript t minus F subscript t. So if we are going to forecast it for, if we take the period, take this t as 1, right? T as 1. So this will be basically forecast for the second period. And this will be the previous week. Because this will be 1, this will be 2, this will be 1. And accordingly, this is 1 and 1. Okay. F3. F3, basically to forecast it for period 3, because we don't have the forecast value for initially for any period. So we just take the sum of the first 2 weeks, 400 plus 380, and divide that with 2. So we get the next value, which is D3. So you simply sum up these two, divide this with 2, you will get D3, and then we can forecast it. So the forecast amount over here is equal to the actual demand. And then forecast for period 4 with alpha value 0.1. So then using this equation, we can forecast it for week 4, which is 392. 392, and this was, I think, the value when we use the simple moving average technique. For week 392, week 5, 394, and so on. And when we extend it to all weeks, we get this pattern. This was the three weeks moving average. This was the 6-week moving average. And now this one is the exponential smoothing. Okay, then we have trend adjustment, exponential smoothing. The issue with the exponential smoothing, although the exponential smoothing is more sophisticated than the simple moving average and the weighted moving average technique, but it fails to pick the trend in data. So if a trend exists in the data, then we use the trend adjustment. And trend adjustment, to explain the trend adjustment, let's first go through this example. Meta-analysis company provides medical laboratory services to patients of health providers. A group of 10 family practice doctors associated with a new health maintenance program. Managers are interested in forecasting the number of blood analysis requests per week. Supplies must be purchased and a decision made regarding the number of I can't see this because there's a line coming here. Okay, the number of blood samples to be sent to another laboratory because of capacity limitations at the main laboratory. Recent publicity about the damaging effects of cholesterol on the heart has caused a national increase in requests for standard blood tests. Meta-analysis recently ran an average of 28 blood tests per week. The trend has been about 3 additional patients per week. This week's demand was 27 blood tests. We use alpha as 0.20 and beta 0.20 to calculate the forecast for next week. So this is the actual blood tests, the data for that. So there is a trend. You see there is an increasing trend, and that is also mentioned in the example. So patients' arrivals and weeks. This is the average demand. Sorry, 80, because in the trend adjustment we aid trend with the जो है क्या है उसकी, basically aid this trend. So this is the equation which is used in this trend adjustment exponential smoothing technique. AT is equal to alpha dt plus 1 minus alpha AT minus 1 plus TT minus 1. This is trend. And to calculate trend, we use beta, or sometimes called beta. T subscript is equal to beta into AT minus 1 plus 1 minus beta into T subscript T minus 1. Using the data given in the example, we can calculate A1 for period 1 and then trend T1. And thus the forecast is this 33. Similarly, for the next periods, and thus we get a trend adjustment. The number of time periods were 15 here. Demand smoothing coefficient alpha was 0.2, initial demand value was 28, trend smoothing coefficient beta was 0.20, and estimate of trend was 3, because it was mentioned that 3 patients every week are increasing. So we can put that in a table form, 15 weeks. Smooth, these are the arrivals, this is the average, then the forecast and error. And then we get the summary. Average demand was 49.8, mean square error, mean absolute deviation, forecast for last week, 17 weeks and 18 weeks. You can further project it. Then we have some seasonal effects. So seasonal effects, I mean, if you remember that demand pattern, in a year there are 4 quarters, quarter 1, 2, 3, 4. There are 4 years data. Example is the manager of the stainless steamer carpet cleaning company needs a quarterly forecast of the number of customers expected next year. The carpet cleaning business is seasonal with a peak in the 3rd quarter and a trough in the 1st quarter. Following are the quarterly demand data from the past 4 years. The manager wants to forecast customer demand for each quarter. Customer demand for each quarter of year 5, based on an estimate of total year 5 demand of 2,600 customers. Based on an estimate of year 5 demand of 2,600 customers. So year 1, quarter 1, this is the data. Quarter 2, 335, quarter 3, and similarly for all the 4 years. If you sum up this, year 1, the total was 1,000, year 2, 1,200, 1,800, and 2,200. And for year 5, the estimate is of 2,600. So these are quarters, year-wise data, their total, their average of this one, this divided by 4, 250, similarly year 2, year 3, year 4. The seasonal index can be calculated from, that is the actual data divided by the average demand. So the actual data, I mean for every quarter you can calculate it. 45 divided by the average 250, similarly 335 divided by 250 and so on. And thus we get the indices for quarter-wise indices for the 4 years. So ये उनके index हैं हर एक के. Similarly, okay. So quarter 1 का index for year 1, year 2, year 3, year 4. उन सबको add कर दें. When we add this, then divide with 4 because there are 4 years. So 0.20. Similarly, the next for which is quarter 2 for year 1, year 2, year 3, year 4, uska average le lenge. So that is 1.30, then 2.00, 0.50. Now the projected demand, the projected annual demand, it was mentioned for year 5, that was 2,600. We can find the average quarterly demand because there are 4 quarters. So when we divide this 2,600 with 450 multiplied by the index, average seasonal index, which is calculated as 0.20. So when that quarterly demand is multiplied with 650 with 0.20, we get the forecast 130. Similarly, for other quarters, for this quarter 845, for this quarter 1300, for this quarter 325. If you add them up, and सबको आप add कर दें, this will be 2600. But these are the quantities for every quarter. In each quarter, you have to produce, or you need to meet the quarterly demand of year 5. Then when we go through these different techniques, then obviously we go to measure the error. इसमें error कितना है? So there are various ways in order to find the error. Error is basically your actual demand minus forecast, right? So actual demand जो भी है आपकी और forecast, तो उसमें जो difference आएगा वो basically आपका error होगा. Then we take the CFE. CFE basically stands for cumulative sum forecast error. So cumulative sum forecast error. Obviously, we take the sum of these, so that will give us cumulative sum. Then mean square error. So mean square error, when the cumulative sum is taken, divided by the number of periods, that will give us mean square error. Then mean absolute deviation. So in mean absolute deviation, we take the summation of the absolute values of CFE divided by n. So that will give us the mean absolute deviation. And then the dispersion within the errors. Dispersion within the errors. If you see, this is error, this is also error, right? So ET is error in time period, and this is the average error. So we calculate sigma, or standard deviation of the errors, and then map, which is the mean absolute percent error. So this is the way we calculate map, or mean absolute percent error. This shows the how do we calculate these errors. So these are various time periods, demands, these are the forecasts. So error is basically the difference in the actual minus the forecast. So we get these errors here, then we square them, find the absolute values, and then the absolute percent error. So these, just to explain that how these errors are calculated. This minus 15 is in fact the cumulative, because when we take the sum of these, so that is basically cumulative sum of forecast errors. So minus 15. This is the E bar, or average of it. There were 8 time periods. Mean square error, standard deviation, mean absolute deviation, and mean absolute percent error. Okay, so that's it. The references I have taken I have taken these, this topic from these 3 various books. You can go back and you can see the forecasting chapter from operations management by Heiser. Some of the definitions and things are taken from there. Mostly it is taken from the operations management book, which is written by Krojewski, Rezben, and Malhotra. And the other one, some of the things are taken from the Introduction to Management Science by Bernard Taylor. Remember, this was just a refreshing kind of lecture to refresh the things which you covered somewhere in the previous lectures, previous subjects, probably in production planning and control. And because the forecasting is the starting point, right? Before we go into details of inventory control, MRP, and other things. So that's why I wanted to give you दोबारा एक टेस्ट आपको मिल जाए उसका फोरकास्टिंग का, ताकि आपको थोड़ी बहुत चीजें जो हैं वो रिफ्रेश हो जाएं. Any question? Any question? Are you there?
Yes, sir.
Yes, sir. We don't have any questions.
Yes, sir.
चलें, थैंक यू वेरी मच. सिर्फ यही आपको आज का जो लेक्चर था, एक छोटा सा लेक्चर इसलिए था ताकि आपको चीज़ें मैं थोड़ी सी रिफ्रेश करवा दूं, और बाकी आप खुद देख लें, क्योंकि अगर आपने अच्छा, इसके साथ में एक थोड़ा सा मटेरियल भी इश्तियाक साहब को कह दूंगा कि वो पोस्ट कर दे, जो मल्टीपल, ये तो लीनियर रिग्रेशन है, मल्टीपल जो है रिग्रेशन, उसकी इक्वेशन वगैरह कैसे बनती है या वो क्या है, वो भी आपको मिल जाए. थोड़ा सा मतलब उसका टेस्ट मिल जाए तो मैं कह दूंगा वो भी अपलोड कर देंगे, जस्ट इन केस आप में से बाद में कोई मतलब पढ़ना चाहे अपनी स्टडी के लिए तो पढ़ सकते हैं. सो इंशाल्लाह we will be with the new topic. Inshallah we'll meet again next week. Okay.
Okay, sir.
थैंक यू वेरी मच. और आपकी जो अटेंडेंस है, आपके जो CR हैं, काइंडली वो दे दें उसको इश्तियाक साहब को, या अगर इश्तियाक साहब अवेलेबल हैं ऑनलाइन तो उन्होंने शायद रिकॉर्ड कर भी ली होगी, ये लेक्चर रिकॉर्ड कर लिया होगा तो उसमें अटेंडेंस आ चुकी होगी. सो इश्तियाक, आर यू देयर?
सर वो छोड़ गए थे शुरू से ही.
चलें, आप ऐसा करें कि जो अटेंडेंस है, आप में से कोई बच्चा वहां पे चला जाए, उसका स्क्रीनशॉट ले ले और वो स्क्रीनशॉट मेरे साथ शेयर कर ले. ठीक है?
ठीक है सर.
हाँ, स्क्रीनशॉट अटेंडेंस का ले लें और वो शेयर कर लें मेरे साथ. बल्कि ये आ गया मेरे पास. Okay, thank you very much. Allah Hafiz.